In part 1, we did some setup for this forest scene and prepared some of our nature geometry for scattering using a simple geometry node. In this video, we'll expand on that by scattering our nature geometry across surfaces with the help of a common set of geometry nodes. These can be the foundation for more extensive geometry node setups. So now let's dive in and create our forest. This is the geometry that we created in the first video. The first thing that we're going to bring our attention to is the fact that we have a subdivision surface modifier on top of our landform. And when you come to place things on your surface with a geometry node, the level is going to be important, and you're going to get a different distribution depending on whether you're showing a level 1 or a level 2 for render, meaning what you see in the viewport is going to be different than the distribution you see during rendering. So what I would suggest is, for predictability purposes, if you're wanting to see the particles be what you're seeing through the camera, let's say you've got a nice tree in a particular position and you don't want that to change, you got to make sure and have the same level for viewport and for render. So let's start out by placing some trees, and then we're going to place some rocks, which is going to have a slightly different node setup, although similar to what we do with the trees. So let's come over here and examine our trees. It's basically the 3 trees that we have from the first video, where we have sub-collections that contain the components that we want for each tree, remembering that this is the collection, this tree, that we're going to be used to propagate, but it's going to choose and randomize each of these 3 sub-collections. So just sort of keep that in the back of your mind. So let's come over here now, and we're in the Geometry Node Editor. Let's go ahead and click New, and then you'll see that a new geometry node modifier has appeared down here right from the outset. Call this Forest Trees Nodes. Let's come over and press A key and then Frame to Selected, and that will show up our 2 nodes. So we have input and output. The mesh that we see here is the input, and it's the exact same, so it shows in the output. So we need to come in and put in 2 of the very most common geometry nodes that you're going to end up using. Press Shift A and do points. We're going to do instance on points, and then A again, distribute points on face. One distributes random points on a surface, and this other one takes whatever object that you want and assigns it to those points. So let's do this. Let's take our geometry from the input and take it into mesh. And then we're going to take that points and we're going to drive it into the output. So there we see a distribution of random points across the surface. Now we want to be really careful with this before we start just taking this and throwing trees on top of it, because you can quickly overwhelm your system with too much data. So let's come down to density. And we're going to drop that down to 0.5. And you can see that really thins that out. That's what we want as sort of a safe starting point. Now let's drive distribute points on faces, the points, to the input points of instance on points. And then when we come over and take instances and drive that to the group output, everything will sort of disappear. And that's because the instance on points doesn't know yet what to work with. Let's come in now and tell this node setup what to use. We have the 3 trees over here, and we've got the master collection called trees. And let's come over, Shift A, and then type in collection, and we want to use the collection info node. We grab the trees, and we drag this over right there. Now we want it to consider each of these 3 sub-collections, these 3 trees, to be individual, independent objects. And it's very important that to do that, you include this separate children and reset children. It's going to separate each of these into individual objects that it can randomize around the scene. And the reset children will allow it to reset the center, the origin that it uses for each of the children. But this brings up a really critically important point. it needs to know where the center of the instance that it's going to create of this collection is, because it's creating internally a collection instance for us. So let's do this. Let's come over to the trio one. I'm going to select both of those components, and shift period, I'm going to bring them into view. Now the object itself has its origin for the trunk down at the bottom, and if I did shift S, cursor to selected, the cursor will jump back there. So we can use that to set the position of the collection instance that it's going to create. And you must remember to do this in advance, otherwise you'll get unpredictable results. So come down here to where we have collection properties and then collection instancing, where it says instancing here, and make sure you do a set offset from cursor. And I've already done that, so the values are propagated there, and that just makes sure that when it creates a collection instance, if I do it manually here, if I do an instance to scene, it gets dropped in the exact position where it currently is. But most importantly, it puts the collection instance's origin right at the same position that we have the parent geometry, and that makes it predictable. Otherwise, what it's going to do, if you don't do this in advance, the origin is going to be at the center of the 3D universe, and your instances are going to be propagated across the surface in a really offset way. So that's a very, very important thing to remember. So now that I've sort of hammered that point into place, we can come back to our forest ground, which is currently invisible because we're not seeing anything yet on it, and we can drive instances here in instance. But there's one more value that will kind of screw you up if you don't add it. This pick instance is a whole part of these down here where we're saying separate children and reset children. In order to really correctly randomize and pick those three instances, this also has to be checked. So now we can come across here and drive that in. And again, it may be that you have too many points in terms of density. You can see here it's already slowing way, way down, and we have scale too big. So I'm going to come in here and put in 0.05, and that will reduce the distribution, and we can pull out and we can kind of see what's going on. So the scale of our trees is simply too big, but you can see here how even with that convex hole, it's a little bit slow. So let's do this. Let's just take the scale and manually input that down to 0.1, and we can kind of see our trees. They're distributed across the phantom surface. In fact, let's come over here. We have groundwater. I don't want you to get confused by that. So let's come back over here and figure out what do we do in case we want to have not only the instances propagated across the surface, but we really would like to see the surface they're being emitted from also, because it may have a texture you want. So let's do Shift A, and we're going to search for a join geometry node. And what we're going to do is tell it to merge the original geometry and also show us the propagated geometry. And the reason it's doing this is because it's using this input, the ground, sort of this pasture object with the pond in the middle. It's using that just as an input, and it's then being replaced by the instances and then output as the output object. So we're going to take instances, drive it in here, and then we're also going to take the original input and add that, and the two will be joined back together, and that will allow you to see the original surface. But we're going to be having multiple surfaces here because we're going to have rocks and grass and flowers. And we don't necessarily want to have to do this on each one, because then we would have overlapping geometry. So what we're going to do instead is let's come back again where we're just seeing the trees. I just wanted to show you that, and I'm going to delete that. And we want to duplicate this. Let's come down here under the geometry node, and I'm going to temporarily turn that off so that we can duplicate this. So I'm going to press Option D. It's important to do duplicate linked, Option D, escape key, and we want to remove in this duplicate here, we want to remove the geometry node, because this is simply going to be the ground plane that exists for our scene. So, you know, our forest floor, if you will. Let's come over here and we'll call this forest floor. Okay. And this forest, I'm going to call this forest dot trees so I know exactly what that's doing. You can see if I come over here and we take a look at this, if we look at this in shaded mode, I've got just this basic texture applied to it that's kind of a repeating pattern. And we have so many things appearing on it that it's only really going to show up in a few places, and it's just a good general repeating pattern as a ground for our scene right here. So that is our forest floor. There are no geometry nodes being assigned to this. Let's go ahead and turn our trees off also. In fact, I'm going to hide that from view, and we'll come back to forest trees here, and we're going to re-enable our geometry nodes for that. So then we need to return our attention to the next component of this, and that is telling the geometry nodes where we want them to go and where we don't want them to go based on the weight map that we painted that tells it where the water is and where the forest is. So let's come in now and pull up a space kind of up over here. We want to control the density. We're going to do two things to kind of make this happen. So far, we've been controlling any parameters over here in the geometry nodes themselves, but from a user standpoint, ease of use standpoint, we want to be able to have a couple of parameters that we can control over here in the geometry node itself. The first one we'll look at is density. Press the N key, and we're over in groups, and you can see there's a geometry in and a geometry out. Select the next one, and then the plus menu here, select an input, and then we're going to call this density. And you can see a density entry happen right here. So our current density is 0.05, and we now have a density entry over here, and we're going to manually drag that and put that into density so that we can control that from here. But it disappeared because the default value is 0.0. So let's do 0.05, and then they reappear for us. Let's press the N key again to turn that off. And now we want to come in, do Shift A, and type in named attribute, or name something until you get named attribute. An attribute is what we have here down in the vertex groups. So we have water edge and water area. Now you can just click over here and it's going to find that. And an attribute is like a UV map or these vertex maps. So we want water area, and we need to bring up a math node to combine that. So we're going to click math here. So let's do this. Let's actually kind of move these out of the way because we need a little bit of room, a little bit of extra room here. The attribute, which is the vertex weight map that we have, vertex values are from 0 to 1 and floating point values in between. And we need to take and multiply the value that we are setting against the attribute values, which are 0 to 1, and it will essentially tell the map not to distribute any plants, trees, etc. in the water area. And this will make more sense when you see this. So I'm going to take the attribute values here, and then we're going to take the density value, which is what we are putting in. Okay, and then let's pull out, we can see this a little bit better. And then this final value that it computes, we put down here into density, and there we go. Except it's the opposite of what we want. So what we have to do is invert the value that's being driven into this multiply by the named attribute. And that's easy. We just invert that. Shift A, and let's do map range. Drop that right in between. And we're going to take the values of 0 to 1, which are coming here from the named attribute, and we're going to go 1 to 0 is the actual map range. So we're inverting them. And there we go. So let's do a quick bit of organizing. I'm going to take these here, and I'm going to select them and then put them into a new frame. And I'm going to name this frame, and we'll call this weight map density, so that that's kind of clear when I can just look at that. And then here we'll take these and we're going to join these into a new frame. And I usually just refer to these as core. These are sort of the core nodes in our geometry setup. Now, the next thing that we want to do is address rotation and scale. We have all of these trees and they're not rotated and they're not scaled. So if we come down and we take a look at these, in fact, you can kind of see there's probably a couple of trees in the water. We can adjust the weight map for that. All of these have the same kind of rotation. You see everything is got the same rotation. They just have random placement. Let's come to rotation first, and let's come down and do Shift A and type in random value. And right now we have the rotation as a vector, meaning X, Y, and Z values. So we need to come down here and we need to tell this to be a vector format. So we have min and max, and that means it can randomly rotate between 0 and 360 degrees type of thing. And we want to specify back here what a value is that we'd like to use in an easy to find area, and then have it randomly pick between the min and the value that's max that we're choosing. So let's do this. Let's come over, press the N key, and let's add another input. And we're going to call this rotation max, something like that. And then N key, we come back up here and we've got that value and we'll drive that in right here. But there's a problem. The format is not correct because we've got a vector. So we need to actually do something, add one more node, and it's called a combine XYZ. And we're going to drop this in between, and it's put it in the wrong place. So let's change that. It's the Z value because we are wanting to rotate around the Z-axis. Our instances are aligned according to the local Z-axis. That's sort of the up vector for all of the instances. And so that's what we need to think about. So let's come back up here to that rotation max, and I'm going to put that in the Z. Okay, so that's the value that we're going to add right here. And then that comes over and it takes all three of these values and puts it into the vector slots, the XYZ vector slots over here. And then it's still 0, so keep that in mind. Let's come over here and take this for rotation and put that in there. So we don't see anything happen right now. But let's sort of zoom in, and now we can come over here and I can begin rotating this, and they begin to take on random rotation values. You can just play with something until you kind of get what you want. And so that is how you would do a random rotation. It's randomly figuring out values between what we put in and the starting point of 0 for the min. So let's come in now and address scale, because currently they've got sort of a single value for scale. They're all pretty much the same scale. We'd like to give some randomization and set the scale itself kind of more properly. So random value, we'll do another random value here. And in this particular case, even though we've got X, Y, and Z, we're not going to be transforming them independently. We're going to be scaling them uniformly. So we can take this value just as it is with float, that's fine, and take it up here and put it into scale. And you're going to notice immediately that it scales them quite a bit larger. And there's some randomization. Some are smaller, some are bigger. So let's come down here and change these, because that default value wasn't quite right, but at least it allowed it to not fill the screen. So let's do 0.3 and 0.4. And that, I think, gives kind of a better distribution. In fact, let's come over here and turn on the ground floor, and we can see that. In fact, let's go back into just a wireframe. And you can kind of see it as it's distributed onto our pond, generally about the size and scale of what we want. But we'd really like to, again, have the values over here so that we can just manually come in and drop them in without having to dive into a complex node setup. So N key, let's come over, select the last one on the list, and we're going to do another input value. And this one we will call scale dot min, and then just immediately do another one. And this one will be scale max. Okay, N key to close that up, and we'll just come up here, take min, and we'll drive that into min, and then we'll take max and drive that over here into max. Now they'll all disappear because it's putting a default value of 0 over here. So let's do 0.3 and 0.4, maybe 0.45 and 0.35, something about like that. Okay, so that is how we would control, and there's randomization to the scale and randomization to the rotation. And so, you know, the great thing is we can look at this from the top now, and if I wanted to come back in and sort of examine part of it, let's say we wanted to come over here and again play with the rotation, you see how I can play with the rotation over here, and it randomly rotates those in one place. Now there's another value that I'd like to put in, let's press the N key again, is that when we come back up to the main distribute points on face, we have seed. Seed is cool. Let's come down here and add one more. Let's input, and we'll call this distribution seed, something like that. Then we come back over here to our group input distribution seed, and we drop it over here. Now we can change the distribution of everything by just putting in a new value. And you can see it does that. And this is actually really handy because let's say you've got a camera in the scene and you're looking at it and you're like, oh, I'd really like to try a different arrangement of my trees and grass and rocks and so forth. You just come over to the seed distribution of distribute points on face, and then you can see how it rearranges to give you something that maybe is more artistically interesting. So come over here and key and turn that off. Okay. So right now I've got this grouping core, and I want to come down here to these, and let's put a group around here, join, and we will call this transforms, which is just a way of saying rotation and scale. So you can kind of see where the different parts of all of this are. In fact, let's take a look at that. Let's go into the camera view here, and let's turn on our pond water so we can sort of see that. And I'm going to come over to a target object that I have for my camera, and you can kind of see how we've got the distribution of trees. And if you just wanted, you're like, oh, I kind of want a different distribution, then you can just come over here and see what that happens to look like. So seed is really useful for that type of thing. Okay, so let's jump in and just take a look at distributing rocks, because we're going to take a look at an alternative version of this very same setup that's adapted for the rocks, because they've got a different rotation property. So let's do this. Let's come over. So I've got floor, and I'm going to turn this off, and we're going to come back over here to floor. We're going to do Option D to duplicate that, escape. And for this one, you know, I don't think we actually need to have our subdivision be at a level of 2. So we're going to take 1 and we're going to do 1. I could probably do this for the tree also, because we're not actually seeing the ground plane. We're just seeing the distribution of points on it. So a lower value is going to work pretty well for what we need to do. Let's just turn off temporarily the forest floor, so we're just seeing this. So we want to come over and we're going to rename this to be larger rocks, something like that. This is going to be the perimeter rocks that go around the perimeter. And if we come over and we take a look at these, let's scroll down. So I have sourced these, and I already have, let's take a look. I already have a convex hole that we did in the first tutorial placed on here, which you can see right here, that gives them that convex hole around them, which is much faster to draw than the native dense geometry. So we don't need to do anything special. It's just all these items propagated within the collection that we're going to be using as the collection info source. So let's come back over here to the rock and the forest rock emitter, as I'm calling it. Now, if we remember, we had done a weight paint for just the perimeter, and we can come down here and change that so we have water edge, Option Z, and we can see that this is just the area that I really kind of want rocks. Some of the rocks will be a little bit above the water, and some of the rocks may be a little bit below the water type of thing. Okay, so let's come back over here to our object. I just wanted us to refresh our memory of what that was. And we're going to click New, and we're going to jump through this again really quick. So again, we can go through it, but I'm going to do this a little bit more quickly until we get to the point that we are looking at that is a variance. And that variance is that we want to position the rocks relative to the normal of the surface. The trees were basically aligned to gravity and they were going up, and so we didn't need to worry about being aligned to the geometry, but that's what we're going to do now. So we'll come over here and we're going to do distribute points on faces and then instance on points, and we'll just come and set this up really quick. I always kind of like to see what the distribution of points is. It's way too heavy. We'll just go back to the 0.05, and maybe we'll just do 1 in this case because the rocks are going to be a little bit smaller. Let's do points there. But what I'd like to do before we actually put the rocks in is let's come in and actually mask it via that weight map of the water edge. So we'll do named attribute, and let's just find that here, and that is the water edge. Okay, and let's kind of make room for what we're going to do here. And then we do math, a math node. To mix that, we take the named attribute, and again, let's just do this for right now. We've got density set to 1. Let's set the density to 1 here, and then we'll just hard code that, so to speak, for right now. And then we're going to take this in multiply mode. There we go, way up there. Okay, so we'll take this and we're going to put that into density. So there you go. So you see now we've only got them around that perimeter area. So let's come in here now, N key, and add an input for density. So there's flexibility in how you set this up. So there we see the density. Let's go ahead and set it to 1 right now so that when we plug it in to density here and we come in, it'll give us matching values. But now I can come over here easily and I can play with that right from the ease of the modifier itself. N key. The nice thing is we didn't need to do an extra one to invert it. So let's come over here and just make sure that we join in a new frame, and we'll call this again, rename weight map density. Okay, so now we need to come in and control the rotation, and we need to add in the collection itself. So let's do that. Collection info. And we'll just put that right there. And then we need to grab the rocks, and we'll rocks larger. Again, separate children, reset children, and then we need to make sure to pick instance. And then we will put these right there. Okay, and then we need to plug it in because so far we haven't plugged that in. We're just seeing the points. So this brings us to what we need to do with this is rotate it so it's aligning to the geometry, because right now all the instances are just propagated so they're aligned exactly the way they were posed. So let's do this. Let's come in and just for right now, let's take their scale down just uniformly like that, and we can look at it, and I'd like to kind of see this in conjunction with the geometry that we're working with. So I'm actually going to temporarily put in the join geometry. So we'll just temporarily put this here so that we can see the relationship between the rocks themselves and the surface that we want them to get aligned to. This will make more sense when we do that. In fact, let me go into perspective mode and find a good location right about like that. I think that's good. Right about like that. So let's come down here into the area that we had used and set up transforms in the previous setup for the trees. And we need to think about what we want to do for rotation here, because we want to take these rocks, which are just sort of jutting out from the surface, because they're rotated in the original position that we arranged them in, and we want them to be more aligned to the surface. So we need to think about how we're going to do that. So we're going to do that with a couple of nodes, and one is called a capture node, capture attribute. And we're going to capture, the attribute we want to capture is the surface normal at the point that the objects are placed. So normal, and that will be driven into this input socket. Now we need to tell it what to do with that information. So we're going to do a Shift-A, type in align, and choose align rotation to vector. It's going to take this alignment information based off the normal of the surface and take the normal. So imagine this purple line, normal, normal, normal is what we're feeding in as the vector for this. Okay, and it's going to use the object's z-axis for that alignment. So then we come up, let's move these back just a little bit, make room for this input. And we take this and we put it into rotation, but nothing's going to happen. So why is that? So there's a technical detail here that will make sense. We first have to tell it to use the geometry of the input surface. Okay, so we'll put that in here and still nothing happens. And the technical detail is that what this node is doing is it's actually grabbing and making a complete duplicate of the source input geometry and then passing that onto the distribute points on surface. And this node function grabbing the normal won't work until this node has that new duplicate of the object where the normal information is also being captured and transported to it. So this, let's move this over. We take this and drive this into mesh, and then those will be aligned to the surface normal because it's actually technically capturing the mesh data from this. It's kind of weird setup, but that's what's happening. So what we want to do now is actually produce some random rotation. Well, I mean, it's kind of random. That looks pretty random to me, but we would really like the ability to further rotate and randomize these around each of their local z-axes, which are aligned to the surface normal. So let's come in here now and just rename this really quick. We'll call this large rocks nodes, like that, so that's clear what's going on. Now, we'd like to be able to put random values in here. It looks kind of random, right? I mean, that could probably work, but it would be nice to be able to manually put a randomization in there, so from an artistic standpoint. So this is where we will do something similar to what we had done before. So Shift-A, a random value, okay? And since we're working with a vector system, X, Y, and Z, we need to change this over to vector. And then let's come back over because we want a single input N key, and we're going to put in another single input that we can control over in the panel over here that we'll call rotation. Okay, and then this N key we will drive into a combine. Since we're just using one value, that we're putting it into a 3-input vector. So A combine XYZ right there, and then we grab rotation, our manual input value that we want to rotate around the Z, and then we take that into max because we're going to be able to randomize between a min value, which are just zeros, and our specified max value. And then we take this and we plug this into rotation. Well, it's 0, so nothing happens until I come over here, and now you see when I begin increasing that, we get random rotation around our normal aligned rocks. Let's go ahead and take and group these nodes that are responsible for the rotation, and we will join them in a frame that we logically call rotation. And we just, let's kind of move that off to the side. Let's bring this out just a little bit more like that. And we're going to now address scale. Let's take note that currently I have that I manually input a scale of 0.25 in each of the 3 x, y, and z fields, but we're not considering this a vector. We're considering these floating point values. We're going to use one value to give it uniform scale. So we come down and we're going to put in again a random value. And then we need to put in, we want to have min and max values over here that we can play with. So n key, come down to the base under rotation, input, and we will call this scale min, and then the next one scale max. Okay, n key, and then we just need to take these input and drive them into our node way down here. And then we do the same thing. Drive this way over, right like that. Okay, now we currently have zeros over here because it does that by default. And we haven't plugged it in yet, so I'm going to put in the same default values here just so we don't have anything visually change when I drive this into scale here. And so let me move all of this over. So now when I come over and I take these values, let's take max, and I begin increasing that and then decreasing this, you see how I can play with these values until I get something that I kind of like artistically. Then we can play with density. You know, we can play like this with density. And then for the rotation, then we can come in and play. And so you see how this is really kind of a cool system when you begin getting a sense for how all of this works and plays together. And that is why I wanted to do a general tutorial on using geometry nodes as opposed to the particle system. So I hope you found this to be a very useful tutorial.